do a little background before we start, and I want to take you back to 7th grade when you learned order of operations, right? And if you had an order of operations problem like 2 squared plus the square root of 9 divided by, say, 9, plus 7 minus 1, something like that. We had this thing, either PEMDAS was one, or maybe you learned please excuse my dear Aunt Sally, right? Which is the exact same thing, just different way of saying it. But that stood for parentheses, right? Parentheses, and then exponents, and then multiply, and then divide, and then add. We know this. Where is radicals? Where's square roots in all this? Okay. So what your teacher told you, if it was on there, and they might have told you, do that at the same time as exponents. Radicals and exponents. Because they're actually the same thing. A square root of 9, or 9 to the first power, is the same as 9 to the 1/2 power. So radicals are indeed exponents. So if you had your calculator in front of you and you did 9 to the 1/2 power, you would get an answer of 3. And if, like, some of the calculators I noticed don't really have, what didn't they have? There's some, can't remember what brand it was. It didn't have a square root button, which was weird. So they had to do all the square roots by fractions. So just know that they're equivalent. Taking the square root into the 1/2 power. And we can take this to many different levels. So what if it's a, yeah. That's kind of sloppy. What if this was 9 to the 3rd power? Square root of 9 to the 3rd power. 9 to the 3/2. So you can tell that the index is always the denominator. So we have also, and if you went ahead and did that, 9 times 9 times 9, I get 729, and then you took the square root of it, get an answer, you'd end up with the same decimal if you just did 9 to the 3/2, or 3/2 is the 1.5 power. Okay, same thing, same answer. Alright, so that's really the purpose of all this, just knowing that we can do any radical as an exponent and vice versa, and we can change it, convert it as needed. Okay. So let's go back and do a few together. Right. Express as radical form. So convert to a radical. Okay. We know it's 11. Okay. So 7, what do we do with that? Is that on the inside or the outside? Outside. Yeah. And try 2 on your own. What does that equal? And you get cube root of 15. 3. Okay. So square root of 300 to the 3rd power. Yeah. If that works. So sometimes these can be simplified, so if we went through, we might be able to simplify this. I'm not going to really focus on that for now, but just how to convert. Okay. Just how to convert. Okay. Now let's do the opposite. If you're given a radical, write it as a fraction. Remember rational? Anytime you see rational in mathematics, that's the same thing as fraction. Okay. Same thing as fraction. A fraction, another word for fraction is when you have a number on the top, number on the bottom. It's a fraction. The number name for that is ratio. So think ratio is a fraction, so anytime you see rational, that means fraction. So write this as a fraction exponent. So this would be 47 to the, that's 47 to the first. And remember, there's no number here, it's automatically a square root. So that's same thing there. And if we throw in variables, so all this is raised to the 1/3. So that's the cube root of all of this. And we could take this a step further. You remember we might just multiply these exponents. So we could say, well, this is 3 to the 1, a to the 5th, b to the 2nd. So 1 times 1/3, that's 3 to the 1/3. 5 to the, a to the 5 over 3. B to the 2 over 3. A two-step process. Okay, try number 6 on your own, see how it goes. Alright, check it out. Let's see here. 162 p to the 5th, all raised to the 1/4. So that's 162 to the 1/4, p to the 5/4. And understand that what we're doing right now is something you might do in the middle of a problem when it's needed. We'd never just do this for the sake of, well, let's just convert it just for no reason. It's kind of like at the end of a word problem. If you get an answer that's a fraction, oh, it's going to take 60 divided by 8 minutes. And it's like, that doesn't make sense. You convert it to a decimal. Same thing here. There's going to be at certain times that a fraction exponent is going to be more valuable to us, so you'll just use it as needed. Right now we're just kind of working on the skill of converting. Alright, this is a good one. Now we have not just a 1, but something else. So we have, what would this be? Cube root, alright, negative 27 squared. Alright. Cube root negative 27 squared. Is that a real number or is that an imaginary number?
Imaginary.
What are we thinking? Why? Imaginary because we see a negative, but some people say real because... Yeah, so a couple reasons. Number one, if you did order of operations, the first thing you'd do would be to square this negative 27, and now it would be a positive number. It would be fine. Someone else might point out that, well, this is a cube root. Is it okay to have a cube root of a negative? What's the cube root of negative 8? Negative 2. It's not imaginary. Negative 2 times negative 2 times negative 2 is negative 8. So when you had an odd index here, it's okay to have negatives. Whenever that's odd, it's okay to have negatives. That is not an imaginary number. We're just so used to doing only square roots, where no number times itself is negative. But we can have 3 numbers, 3 of the same number multiply and get a negative. Okay, that's the rule that changed. Alright, good. So, yeah, I think we'll just start off every class with what's the square root of -8, just to make sure, the cube root of -8, just to make sure we understand that's not imaginary. Alright, so what we got here? A little background. Remember that a negative exponent moves it. So I'm not going to change anything. But when you have a negative exponent, that moves it from the top to the bottom or the bottom to the top. In a case like a number 11, see how they're both negative, so we'll move the whole thing will just flip around. Right? The whole thing will just flip around on like 11 since they're both negative. So it'll be 27, the cube root of 27 on top, and the square root of 144 on the bottom. Right, so negative exponents move top to bottom, bottom to top. What's the cube root of 27? Yeah, cube root of 27 is 3. What's the square root of 144? 12. So this equals 1/4. Again, feel free to use calculators to verify things. You can actually, in your calculator, put 144, make to the -1/2, right? It'll give you an answer that's 1/12, or the decimal that 1/12 equals, since we moved it to the bottom. But use parentheses on that exponent so it works correctly. Okay, good. Anything else? Let's look around. Anything else worry us? We need to talk about. This one? Let's see. Okay, convert it. See what you get. Each one. This one, first one's a cube root. That's 3. Second one's a square root. So this is 8 to the second, 4 to the third. Okay, so what's the cube root of 64? And what's the square root of 4 times 4 times 4 is 64. Oh. Cube root of 64? Yeah, so what number times itself 3 times is 64? 4. Cube root of 64 is 4. What's the square root of 64? 8. So the answer is 32. When we go step by step, it's not so bad. So I warn you, they look very simple, but if you start rushing through it, it gets ugly fast. So just take your time. It's more symbols than anything else. Right? It's basic arithmetic, right? 4 times 4 times 4 is 64. And you have your calculator to do that. So use it as needed. Alright. Doing pretty good. Anything else on the front we need to look at? Okay, you guys know about these now. Anytime you see 1/2, you know that's like a square root. Negative, okay, it's going to be a square root of 16, but on the bottom. So, okay, that's a 4 on the bottom. You start getting a little bit faster the more you do. So the back is going to be your problem set. Okay. We did each of these directions we did on the front. There's just more of them on the back. If you need to do 1 or 2, check with somebody. Then to do the rest of those same section on your own, see if you got it by yourself. Remember, all this is going to be tested on Friday, but it's going to be tested by yourself. I don't want you doing the whole back with somebody sitting right next to them saying, oh, look, we're both done. We got it. And then when you have to do it by yourself, and you have different forms of the same test, it turns out all ugly because you're not used to doing them on your own. So it's good to get help, but just don't rely on somebody always helping you on every problem. Do a few with somebody, then on your own, and then it'll be fine. Okay, tomorrow is more a review, and then we'll do a quiz on Friday just on Chapter 7. What we've been doing this week. So, quiz on Friday just on this week. Okay, but I think it's a very good quiz, very doable. You guys should all do very well.